Okay, let's dive into this. Welcome back to another intensive strategy session. Today, we are taking on the ultimate time traveler strategy for your computer science Cambridge exams. What do I mean by that? I mean learning to see your completed, perfectly scored paper before you even pick up your pen. We are working backwards from success. Whether you're tackling syllabus codes 0417, 0478, 0983, 0984, 2210, or specifically our focus today, the AS and A-Level 9618, this explainer is your ultimate blueprint. We're putting the special purpose registers under the microscope, specifically the Memory Data Register, or MDR. But listen, we aren't just going to recite what it is from a textbook. We're exploring exactly how to extract the maximum possible marks when it inevitably shows up on your paper. Now, I want you to picture two types of students. Let's call them Alex and Sam. Alex overloads his answers with raw computer science facts, just a massive brain dump of everything he memorized about the MDR, but with zero actual analysis. Then there's Sam. Sam rushes. He totally misses the specific command word requirements in the prompt. Both of them walk out of the exam hall feeling confident, and both of them are shocked when they see their papers covered in red pen marks. Today, we're going to fix exactly what Alex and Sam are doing wrong.
Right, take a really close look at this quote on the screen. This is a direct alert from actual Cambridge Examiner reports. It says, students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. This right here, this is an absolute game changer. It's the key to turning those red marks into green check marks. Too often, we treat computer science calculations, especially those involving register contents, memory addresses, or trace tables, as a simple binary right or wrong scenario. You either got the binary converting right or you failed. But the examiners are literally telling us directly that your process is just as valuable, sometimes even more so, than your final destination. Think about Sam rushing through his paper. He does a complex hex-to-binary calculation in his head, writes down the final MDR value, but makes a tiny arithmetic mistake. 0 marks. If he had just shown his methodology clearly on the page, the examiner could have awarded him the lion's share of the points through method marks. A final miscalculation does not have to mean failing the question.
So, here is our roadmap for today's session. Remember, we are working backwards from exactly what those examiners want to see. First, we'll uncover the MDR exam trap that catches out students like Alex. Second, we're going to break down the top 3 examiner warnings so you know exactly what pitfalls to avoid. Third, we'll implement the method mark strategy to ensure you're banking points at every single step. And finally, 4, we'll look at mastering comparative analysis, which is the secret sauce for securing those top-tier grades. Let's get right into it.
Section 1, the MDR exam trap. Mastering the memory data register isn't just about rote memorization. The real trap is thinking that superficial textbook knowledge is enough to secure an A or an A-star. When you're sitting in that exam hall, the syllabus dictates that you need to understand precise definitions, yes, absolutely, but you also need to grasp the deep, underlying causal relationships within the CPU architecture. You need to know exactly how data flows from RAM across the data bus and into the MDR during the fetch-execute cycle. If you just define the MDR without explaining its relationship to the rest of the system, you've fallen right into the trap.
Let's break down exactly how you're being tested. Cambridge uses specific command words that map directly to these 3 cognitive domains. First, you have your foundation, knowledge and understanding. This is your ability to recall precise definitions and conceptual frameworks. But then we step up to application. This is where you have to take that foundational knowledge and use it to solve problems within specific, completely unfamiliar contexts. You can't just regurgitate class notes. You have to apply the MDR's function to whatever unique scenario they throw at you. Finally, the highest tier is analysis. Here, the assessment framework heavily prioritizes logical, structured reasoning over just a superficial breadth of facts. This is where top students use frameworks like PO, point, evidence, explanation, link to structure their computer science answers. You need deep analytical depth to explain why the MDR is holding a specific instruction at a specific microsecond. And before we continue and look at how to actually build these connections, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving on, we arrive at a massive principal examiner secret. Cross-topic connections equals significantly higher marks. This is the difference between an average student and a top-performing candidate. Top students do not view the MDR in a vacuum. Instead, they demonstrate a connected conceptual understanding. They actively integrate their knowledge of the MDR with completely different areas of the syllabus. For instance, they might connect the data flowing into the MDR with assembly language programming concepts, or with low-level data representation and binary floating point formatting. When you can confidently explain how the MDR interacts with other elements to form a cohesive system, you prove to the examiner that you truly understand computer science, and your grade will reflect that.
We are now entering Section 2, Top 3 Examiner Warnings and the Pitfalls to Avoid. Consider this a blaring red examiner alert. We are shifting gears because we're about to uncover exactly where thousands of students consistently lose easy marks every single year. It is one thing to know the theory behind the fetch-execute cycle, but navigating the specific, tricky traps laid out in past papers is a completely different skill.
Principal examiners have painstakingly reviewed thousands upon thousands of past exam scripts, and they have identified a very clear recurring pattern. There are precisely 3 major repeated mistakes that candidates make when tackling questions about the memory data register. If you know these 3 pitfalls before you walk into the exam, you are already miles ahead of the competition. All right, here they are. First up, forgetting to check overflow and edge cases when you're analyzing data held in the register. If you are tracing a calculation and the binary value exceeds the bit capacity of the MDR and you don't flag the overflow, you lose the mark. Second, failing to check boundary conditions. This happens when students don't verify the extreme limits of the data being processed. And third, the biggest pitfall of them all, providing answers that are not specific to the context given in the question. This goes right back to our student Alex. Alex writes a perfectly memorized, textbook-accurate essay about the MDR, but it scores 0. Why? Because it completely ignored the unique context and the specific boundary conditions of the actual problem on the paper. You must anchor your knowledge to the specific scenario they give you. Okay, stop scrolling. Subscribe to our YouTube channel Ace the Exams, at @acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome to Section 3, the Method Mark Strategy. This is where we rewrite your exam approach live. Tackling multi-step calculations, like tracing the exact contents of the MDR through several clock cycles, can feel incredibly daunting. But it doesn't have to be a high-wire act without a safety net. This methodology is designed to rescue your points, ensuring you get credit for your process, even if the sheer complexity of the final calculation trips you up at the very end.
Let's walk through this standardized 5-step procedural sequence. Think of this as your cheat sheet. 1. Identify the key elements of the question. 2. Apply the relevant theoretical principles. 3. Execute the analysis with crystal clear working. 4. Verify your results. And 5. Present your final answer in the appropriate format. Now, I want you to hyper-focus on Step 3, execute analysis with clear working. This is the gold mine. This is exactly where those critical method marks are won. It's about pulling the curtain back and showing the examiner your systematic, logical processing directly on the page. If you skip Step 3 and just magically produce a final hex or binary value for the MDR, you are throwing valuable marks away. Don't be like Sam. Slow down, structure your answer, and show your work.
What's really fascinating is that we can connect this procedural framework directly to your practical programming skills. Yes, the MDR is a piece of hardware, but algorithmic thinking is fundamentally tied to how you should approach exam questions about it. When you look at an MDR trace question, you need to apply step-by-step decomposition to break down the fetch-execute cycle. You need to consider appropriate data structure selection, efficient code implementation when you're writing out trace tables, and rigorous testing of your own logic. Evaluating your performance isn't just a software development concept, it is the exact mindset, the exact analytical depth you need when breaking down complex hardware questions.
This brings us to a critical exam strategy, an interactive challenge, if you will. Imagine you are staring at a complex data source on your paper, a raw string of binary data sitting inside the memory data register. What do? Your job is to extract from those binary representations, perform the necessary calculations, and then draw concrete, evidence-based conclusions. You have to process it logically, show your clear notation, and use the exact right terminology to explain to the examiner whether that binary sequence is acting as a memory address, an executable computer instruction, or just raw integer data, all based entirely on the specific context of the question. We are now entering our final act, Section 4, Mastering Comparative Analysis. This is all about conquering those higher-order assessment objectives in the syllabus.
If you are aiming to push past a standard passing grade and reach the very top tier of marks, this is where you need to focus 100% of your energy. It's about moving beyond just describing things and starting to critically evaluate them.
Let's do a quick comparison. Visually contrast these two approaches. The average answer identifies only the similarities between concepts. An average student might write that both the memory data register and the memory address register are used to temporarily store data. That's true, but it's basic. Now look at the top scoring answer. A top student identifies the similarities and the differences. They actively use comparative connectives like whereas, conversely, or in contrast. And most importantly, they support every single claim with hard evidence from the CPU architecture. Reaching the top tier demands evaluating alternatives and explicitly comparing how different components function together. To truly master this, you need to develop evaluative thinking. Cambridge examiners define this very specifically. It requires candidates to consider multiple solutions or perspectives, analyze the technical trade-offs of each approach, acknowledge any inherent system limitations, and finally, justify their decisions with solid, factual evidence. This is the anatomy of a perfect, justified recommendation. When a Cambridge examiner is grading an A-level paper, this level of mature, critical, analytical depth is exactly what they are searching for. If you can provide this, you become unstoppable.
Real quick, before you wrap up today's strategy session, I want to give you a highly practical memory hack to lock this in. Because the architecture of a CPU involves incredibly precise definitions and complex causal relationships, try using a visual story method to encode these MDR concepts. Picture the data physically traveling down the data bus like a high-speed train pulling directly into the station that is the memory data register. By turning these abstract, multi-step electronic processes into a vivid visual narrative, you'll encode the information much deeper, making it instantly recallable when the exam clock is ticking.
So, I'll leave you with this final, provocative thought to take into your next study session. Are you just calculating the final answer, hoping for the best? Or are you actively proving your analytical depth to the examiner by showing your systematic process every step of the way? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.